This is part of lesson 20F. We're going to find the coordinates of the point where the normal to a curve meets the curve again. So here's example 3. We want to find the coordinates of the point where the normal, which remember normal is your perpendicular line, to this function. So this is a quadratic function, a parabola. It touches at the point 1, comma, -2. And it's going to meet again at another point. So step 1, let's graph this function. So we're going to just use our graphing calculator. Here's our quadratic function graphed out as such. Then there's a point x comma y at over 1 down 2. Okay, and that point. Step 2 is we want to find the equation of the tangent line by first finding the gradient by differentiation. After you find that derivative function, you're going to substitute the x value into that derivative function to find the slope. So if we go back, we want to find the slope of the tangent line at that point. We've done this already in prior lessons. All right, so the original function is your quadratic. F of x equals x squared minus 3. And we're going to find the derivative using our power rule. So we're going to bring down that 2, decrease the power by 1, and then that -3 just becomes a 0. So that's your derivative function. Now if you remember that ordered pair, x comma y was over 1 down 2. So we're going to find the derivatives function's gradient, the slope. So we evaluate that derivative function at 1. Simplify it and we get 2. So therefore that is the slope or the gradient of the tangent line. Step 3 is to find the gradient or slope of the normal. So if you remember, that is a negative reciprocal. So I'm going to go out to this slope and reciprocate and negate it. So m sub 2 is -1 over 2. So that's the slope of the perpendicular line at the order pair 1, -2. All right, step 4 is to now substitute the slope, the x value, and the y value into y equals mx plus b. So the order pair was over 1 down 2. That was your x and y coordinate. And then our slope of our gradient was -1/2. So we're going to substitute those 3 values into y equals mx plus b. So y value is -2, slope is -1/2, x value is 1, and b is unknown. So we're going to solve for b. Sorry about that. So you're going to get -1/2. I'm going to pause this 1 second. Alrighty, so now we're going to go ahead and multiply -1/2 times 1. You get -1/2. And then we're going to add 1/2 to both sides. So -1/2, or -2 plus 1/2. So our b value is -1 and 1/2. That's your y-intercept. All right, so step 5 is to now substitute your gradient, your slope, which was -1/2, and your y-intercept, which we just found to be -1 1/2, into y equals mx plus b. So y equals -1/2 x minus 1 1/2. So that's the equation for your line that's perpendicular at the curve. All right, now step 6 is to use a graphing calculator to find the point of intersection. So here is your curve, your quadratic, and then here is your equation that you just found for your normal line, y equals -1/2 x minus 1 1/2. And what you would do is you would calculate the points of intersection for those. So where did they touch at? So one of them we gave you was over 1 down 2. And then the other one we would calculate with our graphing calculator, and I'll show you how to do that in just a minute. So that point will be at -1.5, comma 0.75, -0.75. So I'm going to go ahead and pull up my calculator here. So you're going to type in the first equation, y equals x squared plus 3. So I just want you to see what that looks like. That's your quadratic. Oh, should be -3, sorry. -3. All right. There's what it looks like. And now we're going to type in that equation for our perpendicular line, the normal line, at y sub 2. So -1/2 x minus 1.5. Graph it out. There's your perpendicular line, your normal line. To find the point of intersection, you want to push your second button. Then this trace, which is calc, and you're going to find that point of intersection, number 5, right here. So type 5. And it's going to ask you for the first curve. So I'm going to go above that intersection. See it there blinking in the blue, and then enter. And then it's going to ask you for the second curve. You want to make sure you're in the red one. Enter. And then enter one more time. And what it's going to do is going to bring you to that point of intersection, and this is the ordered pair here. Let's do this one more time so we can find this point of intersection. So second calc, number 5, and I'm going to bring it close to that point of intersection. Enter. Now just make sure your red curve, your normal curve, is close to it. Enter. Enter one more time, and there is that point of intersection 1, -2.